Section 7.4 Adding, Subtracting, and Multiplying Radicals. So now that we know a little bit about radicals, let's do four basic operations on radicals. In this section, we'll add and subtract and multiply. In the next section, we will divide. Here is the rule to add and subtract radicals. To add and subtract radicals, we must make sure they have the same indices, that's a plural for index, and the same radicands. So there are two conditions you have to satisfy in order to add or subtract radicals. What does that mean? That means what? These numbers gotta look alike, so does the indices. These numbers gotta look alike too. And when they do, all you have to do is add the coefficients and attach the common radical. Do you see it? It'll be clear in examples. Check this out. Suppose you have been asked to add 2 square root of 5 to 6 square root of 5. I gotta make sure two things are satisfied. These numbers gotta match. These numbers gotta match. So if you made sure that the numbers under the radical and indices are identical, indices are the same, radicands are the same, then you are allowed to add, or else you cannot do it. It will be unlike terms, then you won't be able to do it. So how do you add these guys? Well, you don't add the radicals. You don't go, this is square root of 10. You add the coefficients. So you kind of go 2 plus 6 and attach the common radical to your final answer. Therefore, the final answer is 8 square root of 5. Once again, check and see these numbers under the radical. They look the same, and check and see these numbers, so-called indices. They also look the same. If these are the same, then you can what? Subtract the coefficients. So that would be like 16 minus 10. Then attach one of those radicals to your final answer. So in this case, I think the answer is 6 cube root of x. Do you see it? So now, sometimes you get a mixture of the indices. So these guys are like terms, and these guys are like terms. So these guys should combine as well as these guys. You cannot combine all of them at the same time. Okay? Because notice the indices of these guys are 2, whereas the indices of these guys are 3. These are square roots, those are cube roots. So you could add the cube roots first. So that would be the same as 2 plus 4, then attach the what? Cube root of x. Then you can add the square roots by adding the coefficients. In this case, I have to subtract the coefficients, attach the common radical. So the final answer is 6 cube root of x plus 5 square root of x, and there is nothing we can do at this point. This is as good as the answer gets. Do you see it? Sometimes what? The indices match, but the radicands don't match. That doesn't mean that what? We cannot add these guys up. So what you gotta do is you gotta force these guys to look alike. In other words, you gotta simplify these radicals first before you add and subtract. How do you do that? I'm gonna write this as 4 times 2. I'm gonna write 50 as 25 times 2. I'm gonna write 72 as 36 times 2. Okay, so now I know square root of 4 is 2, but guess what that 2 goes? It multiplies by the 5 in front of the radical, so you get this. Square root of 25 is 5. Guess where the 5 goes? It multiplies the 2, then you get square root of 2. Square root of 36 is 6. Guess where 6 goes? It goes in front of the radical, multiplies by negative 3. So now if I clean this up, I get 10 square root of 2 plus what? 10 square root of 2 minus 18 square root of 2. What do you know? Now I got the same radicands, same indices, I'm ready to add. Whereas to begin with, I had same indices, but the numbers under the radical didn't look the same, so I wasn't according to the rule here. I wasn't allowed to add or subtract. Now they all look the same. So what I do, I take the coefficients like 10, 10, negative 18, attach a square root of 2. So that would be like 20 minus 18, which is 2 square root of 2, and that's the final answer. Do you all see it? Same thing goes if you had x's under the radical. Did you know this is the same as 25 times 2x squared minus 3, 36 times 2x squared minus 8x, and 18 is 9 times 2. Remember, the way I split the numbers, I try to split in such a way one of the numbers is a perfect square. Do you see it? So it has a square root. Well, guess what pops out of the first radical? Well, the square root of 25 is 5. Square root of x squared is x. So you will have 2 left under the radical. Every time you pull a number out, what? Inside the radical, outside of the radical, that number multiplies by the coefficient in front of the radical, correct? Well, square root of 36 is 6. Square root of x squared is x. You still got square root of 2. Minus 8x, square root of 9 is 3, and that's as good as the last one gets. Clean this up, what do you get? You get 15x square root of 2 minus 18x square root of 2 minus 24x square root of 2. Now that you got what? Same indices, same radicals, what you do, you kind of combine the coefficients. So that would be 15x minus 18x minus 24x, attach the square root of 2 to the final answer. What is this? This is negative 3 and negative 24 gives you negative 27x square root of 2, and that would be the final answers. And this is how you what? Add and subtract radicals. To multiply, the rule says what? Make sure the radicals have the same indices only. In other words, all I care, these guys match. Whereas before, I had to also make sure the numbers under the radical match. But when it comes to multiplying radicals, I just have to make sure they have same indices only. So how do you multiply? First, you multiply the coefficients in front of the radical. A times b is ab. Then you multiply what? What's under each radical and put it under one radical. So radical, let's say nth root of x times nth root of y is nth root of x times y. So take this guy and this guy, multiply them out, put them under the same radical. So let me show you some examples so you see what I'm talking about. First, make sure these numbers match, otherwise multiplication is not defined because the rule says they have to have same indices. So what do? You put cube root sign and then multiply 2 by 4. So that would be like cube root of 8. Cube root of 8, we know it's 2. Final answer. What about this guy? This guy is the same as cube root of 2xy times itself twice. That's what the power of 2 is, right? Then again, same indices. So what you do, you what? put the product of these two numbers under the same cube root. So that would be 2xy times 2xy. So the answer is cube root of 4x squared y squared. Final answer. Here, you got the square root of 3 times the square root of 5 plus the square root of 7. You need to use distribution law. Notice, check and make sure the indices are identical. Otherwise, you cannot multiply. So, square root of 3 times the square root of 5 is square root of 15. Square root of 3 times the square root of 7 is the square root of 21. And I cannot combine these because the radicands don't match. Sometimes you have two terms in each parenthesis, so you can FOIL this if you so desire, or you can just use distribution. So that would be 1 times 8 is 8, 1 times what? Square root of 5. Then multiply these guys, square root of 5 by 8 plus square root of 5. 8 times the square root of 5 is 8 the square root of 5. The square root of 5 times the square root of 5 is the square root of what? 25. Are we done? Not yet. The middle terms gets to be combined. So this would be 8 plus 1 plus 8 to square root of 5 plus square root of 25. In other words, these guys are like terms. I get to combine them. So what do I get in return? I get 8 plus 9 is square root of 5, but the square root of 25 is 5. But then I can add the whole numbers, and final answer would be 13 plus 9 is square root of 5. Final answer. You all see it. Right? Same thing goes here, except now I have x and y, so that will be square root of x squared minus what? Minus y square root of x plus y square root of x minus y squared. Is that right? These guys cancel because they look alike, opposite sign, but the square root of x squared is x, so the final answer is x minus y squared. This one is 2 square root of x minus 3 squared, which is 2 square root of x minus 3 times itself twice. So now I have to use what? FOIL or distribution law to remove the parentheses. So here's what you do. I kind of go, okay, that guy times that guy is 4 square root of x squared. And then here I get negative 6 square root of x. Here I get negative 6 square root of x. Here I get positive 9. But the square root of x squared is x, so that's 4x. These guys combine, negative 6 minus 6 gives you negative 12 square root of x. Don't forget you still have a 9. And none of these guys are like terms, so the answer is what you see inside the box. Final answer. I could also have what? Two terms in each term, but with cube root, no problem. As long as the indices match, I can multiply. So how do you multiply these guys? You kind of go cube root of 10. Then you would go cube root of 2 times 6 is 12. Then you do the same thing with this guy, which is cube root of 4 times 5 is 20. And cube root of 4 times 6 is what? 24. The only problem is I can split the 24 into what? 8 times 3? Is that right? So this would be the same as cube root of 8 times cube root of 3. And cube root of 8 is 2, so this is 2 cube root of 3. So the final answer is, what's the final answer? Let's just write the final answer for this problem. It's cube root of 10 plus cube root of 12 plus cube root of what? 20 plus 2 cube root of what? 3. And none of these guys are like terms, so they don't combine. So what you see inside the parentheses is the final answer. Thank you.